All right, so 8.1 is called sequence and series. In this section, obviously, we're talking about sequences and series. We're also going to talk about factorials and summation in this section. What is a sequence? So an infinite sequence or a finite sequence, there's two different kinds. An infinite sequence is a function whose domain is the set of positive integers. The function values, a sub 1, a sub 2, a sub 3, a sub 4, all the way up to a sub n, are the terms of the sequence, so some vocab here. And if the domain of a function consists of the first n positive integers only, then the sequence is a finite sequence. So if it said for the first 4 terms, the first 10 terms, the first 15 terms, that's a finite because it stops. If it just says that a sequence is a sub n, meaning there's no end to it, then that would be your infinite sequence. And what you're plugging in, so what those little subscripts are going to start with 1 unless it says otherwise. It will start with 1 and it will go up to however many terms you want it to be. You'll always plug in whole numbers here and positive whole numbers. So the first kinds just say stuff like this. Write the first 4 terms of the sequence and assume n begins with 1. So from here on out, we'll assume it begins with 1 unless it says otherwise. So if you look at A, it says a sub n is 2n minus 4. So I'm going to find a sub 1. It says the first 4 terms. So I'm going to do a sub 1, a sub 2, a sub 3, and a sub 4. And so for each of these, the subscript number is the number you're plugging in for n. So this is 2 times 1 minus 4. This is 2 times 2 minus 4. This is 2 times 3 minus 4, and this is 2 times 4 minus 4. 2 minus 4, which is negative 2. 4 minus 4, which is 0. 6 minus 4, which is 2. And 8 minus 4, which is 4. And then you would list your answers in order that you got them. So negative 2, 0, God bless you, 2, and 4 are the first 4 terms in this series. So B, same set of instructions. This time you're doing a sub 1 again. Would be 2 times 1 over 1 plus 1. A sub 2 would be 2 times 2 over 2 plus 1. A sub 3, 2 times 3 over 3 plus 1. A sub 4, 2 times 4 over 4 plus 1. This is 2 over 2, which is 1. This is 4 over 3. This is 6 over 4, which is 3 halves. And this is 8 over 5. And again, you'd list them. 1, 4 thirds, 3 halves, and 8 fifths. Sometimes they are increasing. Sometimes they are decreasing. It doesn't matter the order of whether their value. You want to go in the order in which you get them. So the first term goes first, second. You're not putting them in numeric order or anything like that. Questions so far? Okay, this one says now find the first 5 terms of the sequence. All right, so again, this time it said first 5 terms. You want to pay attention to the directions, okay? And then you're plugging them in. It got a little bit more complicated this time. We had to plug it in 3 different places, okay? And in a minute, you're going to see that it's going to ask you to actually figure out work backwards. So here's my terms of the sequence. Actually give me the equation of the sequence. You got to work backwards. So the idea behind something like this is pay attention to how you could do things with these series. How would I alternate from positive to negative? It could be something with that -1 to a power. How would I split a whole number into a fraction? Obviously, you can put something in the top and something in the bottom and alter them in different ways. So hopefully this gives you an idea of what it would look like to work backwards, like to get to the equation. All right, example 3 says find the indicated term of the sequence. So instead of a list of terms, it just wants one specific one. This one says a sub 4. So we're just going straight to 4. I would get 4 squared over 2 times 4 plus 1, which is 16 over 8 plus 1, or 16 over 9. So sometimes it'll ask you for a list. Sometimes it'll ask you for just one specific one, and you jump straight there. Questions so far? All right, now we're going to work backwards. So it says write an expression, that should be an expression, for the apparent nth term of the sequence and assume n begins with 1. This time they're giving you the terms in the sequence and you want to find the equation that gets you there. The hardest part for this is like something I can't teach you. This is not like a step 1 do this, step 2 do this, okay? So this is one of those things where you've kind of got to look at and identify a pattern. Don't look at it as what's the difference between 0 to 3 and 3 to 8 and 8 to 15 and 15 to 24. That's not the way you want to look at this. You want to look at it if n is 1, then my answer is 0. If n is 2, then my answer is 3. If n is 3, my answer is 8. If n is 4, my answer is 15. And if n is 5, my answer is 24. So the question is, how do I get from the left to the right where it would be the same thing every time? So can I do the same thing to 1, 2, 3, 4, and 5 to get to the numbers on the right-hand side? Sometimes the first one's not the easiest to identify. Like if you look from 1 to 0, you subtract 1, you get that, but that doesn't work for the rest of it, right? Lotta, what do you see?
N squared minus 1.
Okay, so let's see if it works. If I square the n and subtract 1, this first one would be 1 minus 1, that works. The second one would be 4 minus 1, that works. The third one would be 9 minus 1, that works. The fourth one would be 16 minus 1, that works. And 25 minus 1, that works. So I would say if there's big jumps in numbers, then try to look for things like a power, because usually that's going to help the big jump, okay? Mm-hmm. Sure. This one, I don't know if there's more than one way. I haven't heard more than one way to look at it. Like, that's the way I see it, but there are ones that have different. Yeah, you can have more than one answer. So the way you would write this out is a sub n equals n squared minus 1. You want to give the full equation that would result in this pattern. Okay, now look at B. So if n is 1, it's 2/3. If n is 2, it's 3/4. If it's 3, it's 4/5. If it's 4, it's 5/6. And if it's 5, it's 6/7. So again, you don't want to go 2/3 to 3/4 to 4/5. Like what's changing that way? You want to go left to right here. Anthony. Say again.
N over n plus 1.
Oh, so close. So to get from 1 to 2, because this one I'd have to do what, and this one I'd have to do what? The n plus 1 would be in the top, the n plus 2 in the bottom. Right? So this would be, that would be 2 to 3. This plus 1 would be 3, plus 2 would be 4, plus 1 would be 4, plus 2 would be 5, plus 1 would be 5, plus 2 would be 6, plus 1 would be 6, and plus 2 would be 7. And again, think about what would happen, like what if every other one had a negative, right? If every other one had a negative, then we'd be doing something with like a -1 to a power. Does that make sense? So that you'd be alternating signs because you could see stuff like that. Questions so far? All right, so a recursive series, or recursive sequence, is one in which the terms rely on the term that came before it. So this time there's going to be a pattern moving left to right. And for these, you would need to be given one or more than one of the first few terms. So you can't say, here's a recursive series, give me the first 5 terms, without giving one of those terms. You'd have to have one of those terms. So if you saw this is how a recursive series would be shown. A sub k plus 1 relies on A sub k. So whatever comes before it, I'm going to add 10 to it, and I get a number. And then I'm going to take that number, and I'm going to add 10 to it, and get another number. And then I'm going to keep, that pattern would just be adding 10 in this case, okay? But in order to start it, you need a starting place, okay? You can't just plug in the 1, because notice there's no n in this equation, where we would normally have plugged in n being the number of the term. So now you'd start at 5 and you'd add 10 to it. So this would be 5 plus 10. That's going to give you 15. Now this would be 15 plus 10. That's going to give you 25. 25 plus 10, and so on and so forth. So it's going based on the one that comes before it. Okay? And those you have to have somewhere to start. So it would look like this. Write the first 5 terms of the sequence defined recursively. So here's the first one, and then every one after that is going to be the one that comes before it, plus 3. So A sub 2 is going to be 15 plus 3, which is 18. A sub 3 is going to be 18 plus 3, which is 21. A sub 4 is going to be 21 plus 3, which is 24. And the 5th term, A sub 5, would be 24 plus 3, which is 27. And when you list these, you have to include the first one that they gave you. That's the first of the 5 terms. So it's 15, 18, 21, 24, 27. Questions on that one? So that's recursive when it relies on the one that comes before it. Okay, you do this one. So start with the first part. Write the first 5 terms of the sequence defined recursively, and then we'll try to figure out what's the pattern to write it as A sub n. All right, so recursively, you should have gotten that A sub 2 is 27, A sub 3 is 9, A sub 4 is 3, and A sub 5 is 1. So the first 5 terms in the series are 81, 27, 9, 3, and 1. Now, that's using it in a recursive pattern, right? What it wants you to do is try to figure out in your normal pattern. So if you didn't know the one before it, set up an equation in which the left side would get to you to the right. So how do I tweak that 1 is going to become 81? Something involving 2 would be 27, 3, 9, 4, 3, and 5, 1. Any ideas? This is where it gets tricky, right? This is the worst part, I'll be honest. So obviously there's some sort of pattern with a 3. Yes, like we know we're raising 3 to some sort of a power, yeah? So what is 81? 3 to what power? 3 to the 4th. What is 27? 3 to the 3rd. What is 9? 3 squared. 3. And 3. And 1 would be 3 to the 0, right? So how do I involve these numbers to result in those numbers? So subtract 5 from the number from 5. So n, or sorry, 3.
5 minus 1.
3, so we're saying 5 minus n. Yeah? See if that works. So 5 minus 1, that would be 3 to the 4th. That works. 5 minus 2, that'd be 3 to the 3rd. That works. 5 minus 3, that's 3 to the 2nd. That works. 5 minus 4, that works. And 5 minus 5, that works. So I can say a sub n equals 3, 5 minus n. I've also seen this done as 1/3 n minus 5. So that works too. Okay, this is an example where you could get more than one answer. They're both right. So not every series is going to work like this, like a recursive turned back into the a sub n. But when it asks you to find the pattern, obviously they should. Questions so far? All right, factorial notation. So if n is a positive integer, then n factorial is defined as the n exclamation mark. So if you see the exclamation mark following a number, it actually means factorial. Okay, it doesn't mean say like 3. It's 3 factorial, okay? And what that means is you're multiplying that number times it from starting with that number, decrease by 1 until it hits 1. So if I have 5 factorial, then it's 5 times 4 times 3 times 2 times 1. I stop at the 1. The special case is 0 factorial. So there is no way to work out 0 factorial. This is straight up memorization. You've got to know 0 factorial is 1. Just like a number raised to the 0 power is 1, and there's no way to find that. You just got to know 0 factorial is 1. All right, so this says, write the first 5 terms of the sequence, and now we've got a factorial in it. So I start with the first one, a sub 1. Would be 1 over 1 plus 1 factorial. A sub 2, 1 over 2 plus 1 factorial. A sub 3, 1 over 3 plus 1 factorial. A sub 4, 1 over 4 plus 1 factorial. And a sub 5, 1 over 5 plus 1 factorial. So this would be 1 over 2 factorial, which is 1 over 2 times 1, or 1/2. This would be 1 over 3 factorial, which is 1 over 3 times 2 times 1, which is 1 over 6. This is 1 over 4 factorial, which is 1 over 4 times 3 times 2 times 1, which we already know this is 6, so 4 times 6 is 1 over 24. 1 over 5 factorial, 1 over 5 times 4 times 3 times 2 times 1. We know 4 times 3 times 2 times 1 is 24. 5 times 24, 120. 120. And 1 over 6 factorial, 1 over 6 times 5 times 4 times 3 times 2 times 1, or 6 times 120, which is 720. So this would be 1/2, 1/6, 1/24, 1/120, and 1/720. Okay, so to simplify a factorial expression, let's say I get 5 factorial over 7 factorial, right? And I want to write this out. This would be 5 times 4 times 3 times 2 times 1 over 7 times 6 times 5 times 4 times 3 times 2 times 1. I could go through the work of multiplying out that top row, multiplying out that bottom row, and then simplifying it. Or I could cancel through the ones that overlap. So I can say they both have a 1, they both have a 2, they both have a 3, they both have a 4, they both have a 5. What's left in my numerator is 1. What's left in my denominator is 7 and 6 or 42. Obviously, a heck of a lot faster to do it that way, right? It's even faster if you look at the 2 and take the larger number and break it down until it hits the smaller one. So I would leave 5 factorial as 5 factorial, and I would say that 7 factorial is actually 7 times 6 times 5 factorial, right? Because that would be 5 times 4 times 3 times 2 times 1. And then all you have to do is cancel those out, and it's 1 over 42. So the shortcut or the rule on this is that you want to take the larger, break it down until it hits the smaller, and then you can cancel the smallers out. Does that make sense? Yeah? Okay. Save you a lot of work. Now we've got n plus 2 factorial and n factorial. So I don't know what numbers those are, right? But if I start with n plus 2 factorial and I go to the next number down, what would be the next number down? N plus 1, right? So I'd get n plus 2 times n plus 1. What would be the next number down from that? N. And then I would have to keep going, and I wouldn't know when it would stop because I don't know what number n is. But I do know that if I have an n factorial in the top and in the bottom, they cancel out. And then I would FOIL out what's left. So n squared plus n plus 2n plus 2, or n squared plus 3n plus 2. So you don't even need to know the value of n to know when to stop. You would just take whatever is the larger one. So if, let's say it was n factorial on the top and n plus 3 in the bottom. I would start at n plus 3, and then I'd multiply times n plus 2, and then n plus 1, and then I'd stop at n factorial, and that would be where I'd cancel it out. Questions? All right.